Let's see centripetal force in circular motion. So far we know that centripetal force is something which changes direction, and tangential force is something that changes magnitude of velocity. And since we are interested in centripetal force, we will take a circular case in which velocity magnitude does not change. The thing which changes is the direction. V, its direction is changing, magnitude is not changing. Centripetal force, it changes what? Direction. Ft, it changes what? Magnitude. And therefore, if you look at this, since there is no change in the magnitude of velocity, whatever is acting on the body is nothing but centripetal force. How do you take advantage of this? We know that F is m into A. And what is A? A is dV by dt. If I write down this thing in vector form, then it's like this. F vector is m times A vector, which is m times dV by dt. Now, if magnitude of velocity remains same throughout, if magnitude of velocity doesn't change, then this F is nothing but F centripetal. The first lecture of circular motion, we have seen all these things. Total force will become what? Centripetal force only, provided there is no change in the magnitude of velocity. अगर magnitude भी change होता है तो फिर ये total force, अगर magnitude भी change होता, then this total force is Fc plus Ft, or F, which is the magnitude, is root over Fc square plus Ft square. Ft, since magnitude of velocity is not changing, Ft becomes what? 0. F becomes what? Fc. किसी भी तरीके से देखिए ये चीज समझ में आ जाएगी. Now, this is V, this is V, then this type of circular motion has a special name and you already know it. We call it what? Uniform circular motion. Whatever result we develop for centripetal force with the help of this uniform circular motion, you can directly use that result in non-uniform circular motion. You just need to superimpose Ft over Fc in vector form. We'll see that. अभी के लिए यहां से यहां, then how can you find dV by dt? Suppose this angle is d theta. Why d theta? Because we are discussing changes which took place in time dt. हमारा ऑब्जेक्ट यहां पर था and time was t. जब ऑब्जेक्ट यहां पहुंचा तब टाइम हो गया t plus dt. t plus dt. From this position to this position, it takes dt time. Now, radius is r. From this point to this point, we need what? dv by dt. इसका जो मैग्नीट्यूड होगा दैट विल गिव अस व्हाट f. लेकिन जो f है वही क्या होगा? सेंट्रीपिटल फोर्स. तो फिर अपने को फाइंड क्या करना है? dv. Let's go for dv. What is dv? dv means v final minus v initial. v final minus v initial. And then इस dv का अपने को क्या फाइंड करना है? मैग्नीट्यूड. We are interested in the magnitude of centripetal force because direction we already know is towards the center. Direction we already know is towards the center. We are interested in the magnitude part. Mod of dv is v final minus v initial. यहां पर ये मत सोचना कि that mod of dv is zero. कुछ लोगों को लगता है ये भी v है और ये भी v है. There is no change. We are saying what this whole thing means. Change of velocity. Find that. And then find magnitude of that. v यहां से यहां जब जा रहा है तो डायरेक्शन चेंज की वजह से वेलोसिटी चेंज हो रही है. And everybody knows that if we have got two vectors, vector A and vector B, such that angle between these two vectors is theta, then magnitude of A minus B is given by root over A square plus B square minus 2ab cos theta. ये हमने वेक्टर्स में देखा हुआ है. A and B, there are two vectors. दोनों के बीच का एंगल अगर थीटा है, एंगल फाइंड करने के लिए वेक्टर्स को उनकी टेल से ज्वाइन करते हैं. Then A minus B magnitude is given by magnitude of first vector square of that, magnitude of second vector square of that minus 2ab cos of angle between these two vectors, which in that figure is theta. हमारे पास A और B की जगह पर क्या क्या है? V final and V initial. How do you find V final minus V initial? Magnitude root over first vector, its magnitude square of that. First vector, its magnitude square of that. जो V final vector है इसका मैग्नीट्यूड कितना है? v. This is your initial position and this is your final position. Final velocity, its magnitude is v. Initial velocity, its magnitude is also what? v minus of 2vv into cos of angle between v initial and v final. If you can see that this radius vector has rotated by d theta, that means velocity vector has also rotated by same angle. What I am saying is this: if I rotate blue marker by d theta, then black marker will also rotate by d theta, which means angle between this and this is same as d theta. This has rotated this much. How much? We'll say d theta. Or you can do what? Or you can do this. You can draw a vertical line. This is the vertical line. Draw a horizontal line right here. If this is d theta, this angle is also what? D theta. We know that velocity is always tangential. That means this angle is 90. If this is 90, then this is what? 90 minus d theta. If this is 90 minus d theta, then this is what? D theta. What is this? Initial direction. What is this? Final direction. दोनों के बीच का एंगल कितना है? D theta. and therefore we will be using cos of d theta at this place. अभी क्या बनकर आया हमारे लिए? This is coming v square 2v square. This is also 2v square 2v square 1 minus cos of d theta. Now in trigonometry we had this type of result. Cos of 2 theta is 1 minus sin square theta by 2. My fault. In sin square theta was 1 minus cos 2 theta by 2. इस तरह से आता था. We had this relation cos square theta minus sin square theta. क्या हुआ करता है भाई ये? This is cos of 2 theta. And then this cos square theta, you can write cos square theta as what? 1 minus sin square theta minus of sin square theta, which is cos 2 theta. Now everything is clear. This becomes 1 minus 2 sin square theta. Shift करो and you will get sin square theta as what? 1 minus cos 2 theta by 2. क्या फायदा है इस चीज का यहां पर? यहां देखना. If this is 1 minus cos 2 theta, then this is sin square theta. जो भी यहां है उसका हाफ. हमने बोला यहां क्या लिखा हुआ है भाई? d theta. इसका हाफ करना होगा और इसका हाफ करने का मतलब क्या होगा? This becomes 2v square multiplied by 2 times sin square d theta by 2. 1 minus cos 2 theta is 2 sin square theta. 2 theta की जगह यहां क्या कन्वर्ट हो गया? थीटा बन गया. d theta की जगह क्या आ जाएगा? d theta by 2. Look at the advantage of this conversion. 2v square sin square, and therefore it becomes 2v sin d theta by 2. We can easily take the square root and you get 2v sin d theta by 2. Now next mathematical thing. If theta is very small, then sin theta can be approximated with theta. If theta is very small, sin 0 is what? 0. For large angles you cannot do this. You cannot say that sin 90, which is sin pi by 2, 1. You cannot say that pi by 2 is 1. When theta is very small, we say that sin theta is approximately what? Theta. Now what is d theta? D theta means something which is very small. उसका भी हमने क्या किया हुआ है? हाफ. इसका मतलब साइन के साथ जो भी चीज है, that thing is very small, and therefore it becomes 2v. You can forget about this sign. This is d theta divided by 2, which is v multiplied by d theta. So what is mod of dv? What is mod of dv is coming after this much calculation? v d theta. इस कैलकुलेशन के लिए हमें क्या क्या पता होना चाहिए था? First mathematical part, second mathematical part, third mathematical part. Now once you have this v d theta, अपने से बोला गया find out fc. I have removed the arrow. That means magnitude of fc. Magnitude of Fc is what? Magnitude of F. What is magnitude of F? F is this. Magnitude of F is what? M times magnitude of dV divided by dt. Magnitude of Fc is magnitude of F. Fc, F, what is F? This, what's the magnitude? M times dV by dt. इसका मतलब जो अपना Fc पार्ट है, what is this? Fc is coming M times, look at the numerator, mod of dV, and we have calculated mod of dV. Mod of dV is coming V into d theta. V into d theta, this whole thing divided by dt. Well, mod of dt is dt only, because time is what? Scalar quantity. Mod of dt is what? This. Now, this d theta by dt, what is d theta by dt? This is called what? Rate of change of angular displacement, which we know is angular velocity, and therefore this is omega. D theta by dt, rate of change of angular displacement, which is omega. And then we also know that V and omega, they are related like this. V equals to r omega. Tangential velocity, angular velocity, and therefore this omega is what? V divided by r. Ultimately you get mv square upon r. What is mv square upon r? Centripetal force. That's your centripetal force. You can also find centripetal acceleration. Force is always what? Mass into acceleration. Which acceleration? Centripetal acceleration. M cancelled. We got centripetal acceleration as V square upon R. That's what your centripetal acceleration is. That's what your centripetal force is. You can also represent centripetal force in terms of omega. What is V? R omega. What is V? R omega. V square becomes R square omega square. R cancelled, and you write it as what? R omega square. These are the two important things coming from the centripetal acceleration. Centripetal acceleration is what? V square upon r. In terms of angular velocity, r omega square. When do we use V square upon r? When do we use r omega square? We'll see that. हालांकि दोनों को आप हर जगह यूज कर सकते हो, but कई जगह पर this presentation is more convenient. कई जगहों पर this presentation is more convenient. We have found centripetal acceleration or centripetal force in this article with the help of what? With the help of what? Uniform circular motion. Now, as I told you that if somebody has a situation where V is also changing, even then, if V is changing, even then, your centripetal force will remain what? mv square upon r. क्यों रहेगा? एक तो लॉजिक इस तरह का है कि भाई डायरेक्शन चेंज करने का काम किसका था? सेंट्रीपिटल फोर्स का. तो फिर सेंट्रीपिटल फोर्स वाला पार्ट केवल क्या होना चाहिए? mv square upon r. Second argument is, suppose you found that v is also changing. From this position, which is v, you move to this position, and at this position your V also increases. If V also increases, at this place it becomes V plus dV. A slight change in what? Magnitude. किसकी वजह से मैग्नीट्यूड चेंज आया, एफ टी। लेकिन अगर आपसे बोला जाता गो फॉर सेंट्रीपिटल फोर्स और आप यही चीज कर रहे होते तो यहां v होता और यहां क्या होता, v plus dv whole square, v plus dv whole square. But this dv part is so negligible that ultimately when you go through this calculation part you will arrive at this v d theta only. आप चाहे तो ट्राई करके देख लेना, you will go for what, v square. v square की जगह आप क्या कर रहे होंगे, v square plus dv square. Now let me show you this part here. V plus dv whole square. What is it? V square plus dv square plus 2v dv. What is dv? This dv is something which is almost negligible. उसका भी क्या किया हुआ है, square. And therefore इस पूरे part में v square के comparison में ये चीज क्या है, negligible. Similarly, you're multiplying v with dv. What is dv? A small number. When you multiply a small number like dv with something v, then again the whole thing becomes what? Small. And therefore, out of these three parts, the only thing which is significant is v square. इसका मतलब अगर आपने यहां पर v plus dv square करके भी किया होता तब भी आप दोनों को v स्क्वायर प्लस v स्क्वायर क्या बनाने वाले थे, 2v स्क्वायर. Now note down everything.